The vast universe, with all its splendor and immensity, presents an immense challenge for exploration due to the great distances involved. With our closest solar system neighbor 4 light-years away from us, we will need more than just rockets on this grand adventures. These are the top 5 fastest space travel methods that could one day propel us to the stars. Picture this, a spacecraft unfurling a giant shimmering sail, catching the faint but relentless pressure of sunlight. This isn't science fiction, it's the elegant concept of solar sailing. Just as a sailboat glides across the water, propelled by the wind, a solar sail harnesses the momentum of photons, particles of light emitted by the sun. These photons, though massless, carry energy and momentum. When they bounce off the reflective surface of a solar sail, they impart a tiny push. This push over time can accelerate a spacecraft to incredible speeds. Imagine no need for heavy fuel, just the inexhaustible energy of the sun. The Japanese space agency JAXA has already demonstrated the viability of solar sails with their Icaros mission, successfully deploying and maneuvering a solar sail in space. The future of solar sailing is bright, with ambitious projects like Breakthrough Starshot, aiming to send tiny, lightweight probes to our nearest star system, Alpha Centauri. At a fraction of the speed of light, propelled by powerful lasers, solar sails offer a tantalizing glimpse into a future where we could traverse interstellar distances, riding the waves of light themselves. Now let's delve into the realm of ion propulsion, a technology that sounds like science fiction but is actively being used to power spacecraft today. Ion drives, unlike traditional chemical rockets that burn fuel explosively, rely on a more subtle form of propulsion, the acceleration of ions. Here's how it works. An ion drive uses electricity, often generated by solar panels, to ionize a propellant, typically xenon gas. This process strips electrons from the xenon atoms, creating positively charged ions. These ions are then accelerated through an electric field, creating thrust. The thrust generated by an ion drive is incredibly small, akin to the force you feel when gently blowing on your hand. But here's the key. Ion drives can sustain this thrust for months, even years, continuously accelerating the spacecraft. Over time, this gentle push can propel a spacecraft to remarkably high speeds, making it ideal for long-duration missions. NASA's Dawn spacecraft, for instance, used ion propulsion to journey to and explore the dwarf planet Ceres and the asteroid Vesta in the asteroid belt. Ion drives represent a mature yet constantly evolving technology, offering efficiency and endurance for deep space exploration. The controversial M drive, a propulsion system that has sparked both excitement and skepticism within the scientific community. The M drive purports to generate thrust without expelling any propellant, seemingly violating Newton's third law of motion. For every action, there is an equal and opposite reaction. Proponents of the M drive claim it works by bouncing microwaves within a specially shaped cavity, creating a difference in radiation pressure that results in thrust. This concept has been met with considerable skepticism as it challenges our fundamental understanding of physics. However, several experiments, including some by NASA, have reported detecting a small but measurable amount of thrust from M drive prototypes. These results are far from conclusive and have yet to be definitively replicated. The scientific community remains divided on the M drive, with many attributing the observed thrust to experimental errors or yet to be understood phenomena. Whether the M drive ultimately proves to be a breakthrough or a dead end, it highlights the importance of pushing the boundaries of conventional thinking in our quest for faster space travel. Let's journey into the strange and fascinating realm of quantum mechanics, where we encounter the enigmatic concept of virtual particles. Virtual particles are not like the particles that make up matter. They flit in and out of existence in the vacuum of space, constantly appearing and disappearing. These ghostly particles, predicted by quantum field theory, carry energy and momentum, and some scientists believe we might one day be able to harness them for propulsion. One theoretical concept proposes using carefully manipulated electromagnetic fields to create a difference in the distribution of virtual particles, generating thrust. This idea, though still in its infancy, is theoretically sound, based on the principles of quantum mechanics. However, the technological challenges involved in manipulating virtual particles are immense. We would need to create extremely strong electromagnetic fields and develop a deep understanding of how to control the fleeting interactions of these quantum entities. Virtual particle propulsion remains highly speculative, but the possibility of tapping into the seemingly empty vacuum of space for a source of energy and momentum is an alluring prospect for the future of space travel. A truly mind-boggling concept, the Bussard Ramjet, a starship that fuels itself as it travels through the vast expanse of space. Imagine a spacecraft with a gigantic magnetic field, hundreds or even thousands of kilometers wide, acting as a cosmic funnel. This magnetic field would scoop up interstellar hydrogen, which is thinly scattered throughout space, and funnel it into a fusion reactor. The fusion reactor would then fuse the hydrogen atoms, releasing enormous amounts of energy to propel the spacecraft. The beauty of the Bussard Ramjet is its potential for continuous acceleration. As long as it travels through regions of space with enough interstellar hydrogen, it could theoretically approach the speed of light without carrying vast amounts of fuel. However, the Bussard Ramjet faces significant technological hurdles. Creating and maintaining a magnetic field of that magnitude would be an immense challenge, and achieving stable and efficient fusion reactions is no easy feat. As we conclude our exploration of these extraordinary space travel methods, one thing becomes clear: the human spirit of exploration knows no bounds. The stars are not the limits, they are our destination. The technologies we've discussed may seem like science fiction today, but history has taught us that yesterday's dreams often become tomorrow's realities. The universe is unimaginably large, and our brains can't even begin to comprehend such vast distances. If we ever want our civilization to evolve enough to leave our home solar system, and our survival might depend on that, we'll have to achieve a faster method to travel through space. To learn how ridiculously large our universe is, watch the next video.